Our group had a great idea for the physical computing activity. We took a pre-existing lesson and used the microbit to add an element of computational thinking and coding to that pre-existing lesson. In the original lesson, students had to design their own parachute to descend as slowly as possible. Originally, they had 4 variables to decide upon: the canopy, string, fasteners, and payload. This project changes the payload to a constant variable, being the microbit and the battery pack. So students must now make decisions to support the new constant variable. The other difference in the original activity was the data collection. So after the planning stage and design and construction, the testing phase has now changed. The original activity, students timed the descent of the parachute in seconds. Each descent had a time. The change now tracks 3 intervals of speed during one launch. This gets an average velocity of the descent. The code is intervals, 1 second, each for 3 seconds, collecting acceleration. So the microbit will show number 3, wait for 1 second, collect the speed of acceleration. Show number 2, wait 1 second, collecting the speed of acceleration. Show number 1, wait 1 second, collecting the speed. After the launch and descent has happened, students can then push button A on the microbit, and the microbit will display the speed at that interval and then show the string for second 1. And it does it for all 3 intervals. So students can collect the data of 1 descent at 3 intervals, finding an average velocity. Students did have to make sure that the microbit was protected, and so using bubble wrap was a great and lightweight alternative. And they also used a light adhesive Scotch tape to attach the strings. Students then downloaded the code into the microbit, and they were ready for their lunch.
Start counting. You ready? All right, I'm push the A, B button. Go. Start counting.
After the launch, students then were able to collect the 3 interval speeds and find the average of the velocity.
Push A, it should tell us the speed. So it was 6.6 for second 1. Loading? No, it's going to tell you it was 336. How do you know for that? 2. See the numbers that come across? Watch. 152. Awesome. Okay, so see.
So students then took the speed at the 3 intervals and found the average speed for the launch. The way that the microbit measures speed is in millig's, which is 1/1000th of a g, and a g is as much acceleration as you get from Earth's gravity. So g equals Earth's gravity. So it was a great experience with the students, and they were really excited to try some other things with the microbit.